per week while they're studying. Then we can see there, so that's about 30 students spend between 10 and 20 hours on extracurricular activities per week, and then it becomes less and less and less and less as we go on. And we see there's one student that spends between 60 and 70 hours on extracurricular activities per week. Maybe studying is an extracurricular activity for them. I'm not sure. So again, histograms are very useful because they very quickly give us an idea of what the data density is that we're working with. For a variable, we can see the shape of our data, and we can actually spot outliers as well. There's this small trick when we're drawing histograms is we decide on the bin width. We decide on how wide each of these bins should be. So in this case, we picked a bin width of 10. So we're counting the number of observations in intervals of 10, but we have complete control over that. We can make it for 5, we can make it for 20, we can make it for 40, we can make it for 50. And there's not a general rule that you can actually use that will always give you the correct bin width. You're going to have to play around with it. Okay, so again, the bin width influences how useful the data is, how useful the analysis is. So here is that same graph as previously, but they just use different bin widths. So the first one, they used bin width that's 50 wide. So they counted the number of students that spend between 0 and 50 hours on extracurricular activities. And they counted the number of students that spend between 50 and 100 hours on extracurricular activities. Okay, and here they had a bin width of 10. So they just worked with intervals of 10. Here they worked with intervals of 5, and there they worked with intervals of 2. So the question now is, which one of those are useless? Doesn't tell us anything about our data. Okay, so where do you think the average is for that one? We have no idea. It's somewhere between 0 and 50. We can't really see the shape of our data. I mean, we can't even see if there's outliers in our data or where that is. So again, if your bin width is too wide, you're just basically splitting your data into 1 or 2. So either higher or lower than that value, which is pretty useless. So in this case, if your bin width is too wide, you don't see too much. You don't see enough to say something about your data. And the opposite is also true. If your bin width is too small, then you start tracking individual entries. So then you start tracking individual entries, so you start to see the variance per entry per entry. So in this case, this actually shows us too much. This one is showing us too much because we have all these different peaks and downward areas and stuff, so that's not enough. We don't know whether that's just due to chance because we're working with random data, or whether that's really the shape of the data. So the trick is to get something that's here. When we don't get to a point where individual values start to influence how we analyze the results, but it's still enough that we can actually see the shape of the data. And we can see where the center is, are there any outliers, or are there anything sticking out? Yep.
So would that not be also due to using a smaller sample size? So if you use a bigger sample size, that you can then reduce your bin.
This is a very good point. The point there is if you have more samples, can you then use smaller bin widths? And yes, definitely, because then the individual counts won't make that bigger difference. Okay, so you're right. And that's why there's no formula to calculate the bin width. So if you have a lot of data, then yes, you can work with smaller bin widths. So when we do this analysis, we play around with the bin widths to see which picture gives us the best result. Which picture can we actually analyze to see what's going on. Okay, so when we look at histograms, histograms give us a way to actually analyze the data, and using this we can actually describe the shape of the distribution. And there's 3 things that we're looking at when we're describing the shape of the distribution. The first one is modality, which is the number of peaks that we have in our distribution. And the second one is skewness, and the third one is outliers. Okay, so the first one we're going to look at is modality. So there's basically 3 forms or 4 forms of modality. The first one is a single modal distribution, meaning our distribution has 1 peak. Our histogram is only 1 peak. The second one is bimodal, which means our histogram has 2 peaks. And then multimodal is our histogram has multiple peaks. And the last one is uniform, which means our data has no peak. We can't really see any peak in our data. So in this case is unimodal. There's only 1 peak in that variable. Okay, for the second one, if we drop a piece of spaghetti over the second one, how many prominent peaks will there be? There will definitely be two. So our spaghetti string will go there and then up again there. So we will probably see two peaks in our data. So we can say that one is bimodal. For the third one, how many peaks do you think you'll see there? 2 or 3. It becomes difficult. So again, this is not an exact science. There's no formula for it. We just look at the data and try to see whether there's clearly more than one peak. So in this case, it will either be bimodal or multimodal. We're not really sure there. Okay, for the last one, if you drop our spaghetti string there, how many peaks will we have? We will have one flat peak. So that is then uniform. Our data will be uniform. If we drop our spaghetti string there, it will probably lie on top and then down again there. So there won't be a clear prominent peak in our data. Okay, so again, this is how the first step in describing our data is we check the mode. So how many clear peaks are there in our data? Okay, so quick question here. What could possibly explain a variable's distribution being bimodal or multimodal? Okay, so what do you think could possibly explain our variable being bimodal or multimodal? Is it we made a mistake in collecting the data? There may be a blocking factor that we didn't take into consideration. The variable is simply random, therefore there is no explanation for the multiple peaks. Or the variable is associated dependent on another variable. Okay, do you think is 1, 2, 3, or 4? Okay, let's see if we can get to 200 votes. To 50. Okay, 2 and 50. Okay. that is a BES record. Thank you. That's really a BES record. Last year we were about 50 per class. Okay, so here there's a split between 75 and 127. And some of you said 68, and some of you said 6. The answers may vary, but typically it's because of B. It's typically because of B, because there's actually a blocking variable in our data. Meaning there's actually a factor that we don't have control over that's actually driving that distribution. So as an example, if you were to measure the height of everybody in a primary school, that distribution will be bimodal. Because we're going to have a clear peak for toddlers, and we're going to have a clear peak for the teachers. Okay, and that actually means there's a blocking variable in our data. We actually need to split our experiments or observations between adults and children. So often when we see this simply means there's two distributions that we're looking at the same time. So again, with the height of everybody in a high school or a primary school, that will be the children, that would be the teachers there. Okay, so often when we see something is bimodal or multimodal, we first look if there's not a blocking factor that we need to take into consideration. And after introducing the blocking factor, then oftentimes our data becomes unimodal, single modal between the different distributions. Okay, so just keep that into account. Okay, the second one, or way we analyze data, is we look at the skewness of the data. So here data can either be right skewed, left skewed, or symmetrical. And this one can get a bit confusing. Zane, my assistant, messed it up in a YouTube video, so we had to shoot it again. So even our assistants get confused with this sometimes. Skewness is defined by the tail of the distribution. So if you want to know if our data is skewed, the first thing we look at is whether there's a tail or not in our distribution. So what we mean with a tail is we can see our data is sort of peaking there. There's a lot of data there, and then the observations become less and less and less and less and less. So that less and less and less and less becomes a tail. And the direction of the tail determines whether the distribution is right skewed or left skewed. Okay, so in this case, our tail is going towards the right. So that means that distribution is right skewed. Okay, the reason we describe the distribution of our data, we can look at first, what's its mode? Is it unimodal? bimodal, multimodal, or uniform. We can look for whether it's right skewed, left skewed, or symmetric. Or we can look for outliers to see if there's any outliers in our data. Okay, so the first question here is, how would you describe the shape of distribution of hours per week student spends on extracurricular activities? Okay, so let's go through that quickly. Okay, so in this case, our data has one prominent peak. Our data has one prominent peak, so our data is unimodal. Our data has a tail. We can see it's running off to the right. So our data is right skewed. And again, there's potentially an unusual observation at 60 hours per week. Okay, so that is how we describe data when we actually look at histograms. Okay, so the commonly, just to summarize this, the commonly observed shapes of our distributions is modality. It can either be unimodal, bimodal, multimodal, or uniform. So that just depends on how many peaks there are. And again, if there's no peak at all, then it's uniform. And then the skewness is right skewed, the tail goes to the right, left skewed, the tail goes to the left, and then symmetric, meaning it seems that there's an even amount of observations to the left and right of our average. Okay, so practice question for Swipe. Which of these variables do you expect to be uniformly distributed? So which one of these variables do you expect to be uniformly distributed? The weights of adult females, the salaries of a random sample of people from North Carolina, so that can be Gauteng as well, it will be the same. House prices, so we can say house prices in Gauteng, or birthdays of classmates, meaning the day of the month in which they got born. Okay, so which one of those do you think will be uniformly distributed? Okay, so let's look at the results. Okay, so some of you said weights of adult females. Very few said salaries. Quite a number of you said house prices. And then the most said birthdays of classmates. Okay, so in this case, the correct answer is birthdays of classmates. That's the correct answer. And remember, that's just the day. That's just the day between 0 and 31. Okay, that would be uniformly distributed. How we can reason through this is, do you think there's any reason why more people will be born on the first of a month than the second of a month? Can you think of any reason why that would be the case? Okay. So it's 28th of February plus 9 months. Okay, sorry to burst your bubble, but birth rates are always also random. It's not exactly 30 times 8 or 9 months when you go after. Okay, so there's no reason why we expect one day to be more prominent than another day. That's why it's uniformly distributed. We will, however, see a little dip on the 30th and on the 31st, because there's less months with 33 days in it. They're all with months with 30 days. Okay, but otherwise it would be perfectly uniformly distributed. Okay, so just a further exercise, we're going to look at A, B, and C and try to see what the distributions are of A, B, and C. And this is quite tricky. And there are questions like this in the pre-scrub textbook as well that you have to do. Okay, so what is the shape of the distribution of the weights of females? You think it will be unimodal symmetrical, unimodal left skewed, unimodal right skewed, or unimodal uniform? Okay, I'm going to view the results at 200. Okay, settle down. Sure. Okay, it looks like the answers in this case is uniformly distributed. In this case, it would be unimodal symmetrical. It would actually be unimodal symmetrical. Natural processes tend to be unimodal symmetrically distributed. Okay, it will definitely not be uniform. It will not be uniform. So do you think the probability of somebody weighing 20 kilograms is the same as somebody weighing 50 kilograms? An adult female. How likely is it to find an adult female that weighs 20 kilograms? It's quite rare. It's very rare. How likely is it to find an adult female that weighs 160 or 180 kilograms? Again, it's very rare. So again, most female weight will be somewhere between, 50 and 70 kilograms. And then as you move away towards the right and the left, it will become rarer and rarer and rarer. Okay, so this is why it's symmetrical. It will be rarer and rarer as you move to the edge over there. Okay, next one. What is the shape of the distribution of annual income in Gauteng? What do you think is the shape of the distribution of the annual income in Gauteng? Okay, let's view the results. Okay, some of you said unimodal left skewed, some of you said unimodal right skewed. The right answer there is it's unimodal right skewed. There will be a very long tail towards the right. Okay, how we can analyze this is you cannot earn less than 0 rand at a job. They cannot pay you less than 0 rand. If they do, please get a new job. That means you're paying them. Okay, so there's a national cutoff at 0. And especially in Gauteng, there would be a lot of people that earn close to 0 and between 0 and let's say 4,000 rand per month. That's where most of the people will fall into. Then you get richer people that earn between 4 and 8. Then you get, but they'll be less. Then you get, again, you get people that's even richer, between 10 and 20, they will be less. And then it goes on and on and on. And then you will end up with billionaires. Guys earning more than R1 million per month. Okay, so most of the guys would be on the left, next to 0, and then it become less and less and less and less and less until you reach your multi-millionaires living in Gauteng. Okay, so the tile goes towards the right, therefore it's right skewed. Okay, the last one is, what is the shape of the distribution of house prices in Gauteng? So this is how much a house costs. What do you think is the shape of that distribution? Okay, I'm going to view the results at 200 again. Okay, so in this case, some of you said symmetrical, some of you said left skewed, some of you said right skewed. Here again, it will not be symmetrical. It's going to be skewed again because you will always have these properties that are worth a lot. That are worth 40 million, 50 million rand. But again, you won't have properties that's less than 0. Maybe a hijack building, I don't know, maybe they will pay you to take a hijack building over. But again, we expect it to be right skewed, unimodal right skewed. But in this case, it will actually increase a bit. So there's going to be a very few properties that is close to 0, but there will be a few. Then it will increase, and there will probably peak at about, I think, about 200,000 rand, 300,000 rand. And then it will become less and less and less as your properties become more expensive, more expensive, more expensive. Okay, so in that case, it will again be unimodal right skewed. So to figure out if something is going to be skewed, what we typically look at, we look at a hard cutoff. If it can't be less than 0, and we know there's stuff that's going to be much more than 0, and most will be around 0, then we know it's right skewed. So that's just one trick that you can actually find the distribution. Okay, So in this class today, we looked at averages, we looked at the spread, we looked at everything. And as I mentioned, the average is the most often used and abused statistic. So I'm just going to quickly look at a video that actually described the world's most typical person. So what they did is they looked at the demographics of the entire world, and then they looked at what is the average per person, and see by how much you actually relate to this average person. Okay, thank you. That's it for today. Then I'll see everybody again on Thursday morning.